Your application code can stay completely untouched while your AI product's behavior changes. Someone can edit a prompt template, a guardrail can become weaker, or a different model version can respond differently to the exact same instructions. None of those changes requires a conventional logic edit. And yet, every one of them can change what your users actually experience. In this tutorial, we're going to turn the instructions controlling that behavior into artifacts your team can review, version, and test. We'll build a lightweight workflow around one core idea. If an asset influences application behavior, changes to that asset should be visible, attributable, approved, and checked. By the end, you'll have a practical loop that covers prompt assets, model versions, expected behavior, hostile inputs, and information leakage, without turning this into a sprawling survey of every possible AI control. First, we need to define the behavioral surface. Prompt templates and guardrails influence what an AI application does. So, the useful engineering interpretation is that they belong inside the change process. In practical terms, treat them like code by applying approval, versioning, and testing practices. That doesn't mean a prompt suddenly becomes conventional application logic. It means the prompt's influence on behavior gets a comparable level of discipline. Picture the application as two connected layers. One layer contains the conventional logic. The other contains the maintained instructions that shape model behavior. If you review only that first layer, you're leaving part of the product outside the review boundary. This workflow brings the second layer clearly into view. And the immediate objective isn't perfection or guaranteed safety. It's a traceable process that makes behavioral changes easier for the team to inspect, discuss, and evaluate. Before prompts can be reviewed or tested, you have to make their intent explicit. For coding assistance, start with a broad goal and then follow it with the specific requirements. From there, make 4 practical details unmistakably clear: the problem, the relevant context, the expected result, and the stopping condition. You can think of the broad goal as the destination, with the requirements defining the boundaries of the route. The problem explains what actually needs to change. The context gives the assistant the information that matters for the work. The expected result describes what a successful output should look like. And the stopping condition tells the assistant when the task is complete. This isn't a general formula for writing some perfect prompt. It's the minimum structure you need to make an instruction reviewable. If the intended outcome is still trapped inside the author's head, neither a reviewer nor an evaluation can reliably judge whether a later edit preserves that intent. Now it's time for the first checkpoint. Hand that maintained instruction to a reviewer and ask whether they can identify the goal, the specific requirements, the relevant context, the expected result, and the stopping condition. They shouldn't have to infer those elements from some conversation that was never recorded, and they shouldn't have to guess what counts as done. If even one of those 5 parts is missing or ambiguous, clarify the instruction before you continue. This checkpoint matters because every stage that follows depends on it. Approval needs a clearly stated intent to approve. Version history needs meaningful changes to display, and evaluations need expected behavior they can actually check. Making the instruction explicit gives the rest of the workflow a stable reference point. It also makes disagreements productive because reviewers can discuss a visible requirement instead of debating different assumptions about what the prompt was supposed to mean in the first place. Step 1 is putting your prompt assets under version control. Treat prompt templates and guardrails like code by turning every modification into a visible, attributable version change. The practical value here is traceability. Instead of noticing that behavior has shifted and then hunting through a trail of undocumented edits, the team can inspect the maintained artifact and see exactly what changed. A useful change view should clearly expose additions, removals, and the identity associated with the change. This workflow doesn't depend on any particular hosting service or command. The requirement is simply that the asset, along with its history, is maintained in a versioned form. You've reached the checkpoint when an edit to a prompt or guardrail appears as a visible change that can be attributed and reviewed. Once that's true, behavioral instructions stop acting like hidden configuration. They begin acting like durable engineering artifacts that the team can inspect over time. Step 2 is requiring approval for behavioral changes. Version history tells you that a change happened. Approval determines whether that change is allowed to proceed. Put modifications to prompts and guardrails behind a review requirement, and then make the intended behavioral effect part of that review. A formatting-only review just isn't enough here. The useful question is, what output behavior is this edit supposed to change, preserve, or restrict? That question follows naturally from treating prompts as behavioral artifacts instead of ordinary text files. The reviewer can compare the stated intent with the actual diff and, next, with the evaluation results we're going to attach. The checkpoint here is completely unambiguous. The change can't proceed until the required review and approval are in place. That barrier matters because an unreviewed instruction edit can change output, weaken a guardrail, or contribute to information exposure, all without a conventional application logic change ever drawing attention to it. Step 3 is attaching repeatable behavioral evaluations. Production AI applications should pin model versions and run evaluations to manage changes in model behavior. Pinning is important because both the prompt asset and the model version affect the result you observe. If they both change during the same comparison, it becomes much harder to understand what the evaluation is really showing you. With the model version pinned, rerun the same evaluation set against the changed prompt asset. Include cases that represent the expected behavior and record whether each output meets the stated result and the guardrail requirements. The goal here is repeatability. You need to be able to bring the same cases, the pinned model version, and the changed artifact together again. This isn't a claim that one passing run eliminates behavioral risk. What it creates is a consistent validation path that reviewers can inspect and repeat. The checkpoint is complete when the evaluation set can be rerun against that pinned model version and the proposed prompt changes. One common mistake is testing only the happy path. A suite filled with normal, expected requests may show that the primary task still works, but it can't demonstrate how the guardrails behave when the input is hostile or deliberately designed to trigger disclosure. Evaluations for AI applications should explicitly test adversarial prompts and information leakage. Add both of those categories to the repeatable set. Adversarial cases challenge the restrictions you're maintaining. Leakage cases check whether the resulting behavior exposes information that shouldn't appear. These tests belong right beside the expected behavior cases, not off in some disconnected exercise, because they're evaluating the same prompt asset and the same pinned model version. Be precise about what you can conclude. Passing these cases doesn't guarantee security or eliminate behavioral risk. It means the team has deliberately tested more than the ideal route. Without those cases, the evaluation suite leaves two required dimensions of guardrail behavior completely unexamined. This workflow becomes much easier for coding agents to follow when the repository includes a maintained project map. Repository-level instruction files can cut down on unnecessary code-based exploration by directing an agent toward the areas that actually matter. That map should identify where the prompt assets live, which requirements govern those assets, and which validation path has to be followed. In this workflow, that means pointing to the maintained templates or guardrails, the explicit task structure, the approval expectation, and the repeatable evaluation path. The map isn't a replacement for versioning, review, or testing. Its job is to connect those pieces so an agent can find them without wandering around unrelated sections of the project. You've reached the checkpoint when the repository instructions can guide the agent to the relevant prompt assets, requirements, and validation path without unnecessary exploration. And that map needs to stay maintained as both the project structure and the workflow continue to evolve. Now we can see the completed reviewed artifact loop. First, prompt templates and guardrails are versioned. which makes their changes visible and attributable. Second, behavioral changes require approval, and the review considers the intended effect, instead of looking only at formatting or conventional logic. Third, the model version is pinned and the evaluation set is repeatable. Fourth, that evaluation set covers expected behavior, adversarial prompts, and information leakage. And fifth, repository-level instructions give coding agents a maintained project map that links the relevant assets, requirements, and validation path. A proposed change now moves through one coherent sequence. Clarify the instruction, record the edit, review its behavioral intent, run the repeatable cases against the pinned model, and approve it only through the required process. The result isn't a promise of zero risk. It's a lightweight engineering loop that makes a previously hidden category of behavioral change reviewable, traceable, and testable. Don't begin by trying to overhaul every prompt in the entire system. Pick one existing prompt template or guardrail and apply the full loop to that single asset. Make its goal and requirements explicit. Check that the problem, relevant context, expected result, and stopping condition are all visible. Put the asset under version control. Require approval whenever it changes. Pin the model version used for validation. Then create a repeatable evaluation set that covers expected requests, adversarial prompts, and information leakage. Finally, update the repository-level instructions so an agent can find the asset and follow the required validation path. Once that first asset has completed the loop, use it as the working pattern for additional prompt templates and guardrails. The useful milestone isn't how many files you've migrated. It's having one complete example that your team can inspect, repeat, and extend as the workflow grows. Subscribe to NeuralStack for more practical workflows around AI, software development, and open source. And if you apply this loop, leave a comment and tell us which prompt asset you chose first.